Good evening and welcome to a live stream where we will be experimenting with putting on a solder mask. In previous live streams, working with making circuit boards from scratch, we've used this method to expose a photosensitive layer on a copper-clad board and then etch it to create the actual circuit board. And without any protection, the circuit board will be exposed to the elements, it will start to corrode, and have the potential to short the traces out. And this is the circuit board that we were able to create on a previous live stream. And as you can see, without this coating, we are getting a discoloration of the copper, and that is just corrosion from atmospheric moisture, fingertip grease, all of that sort of stuff, and it is marking the board up. So realistically, we need to get a solder mask on here nice and quickly. So we've got a failure that we're going to be experimenting with. We've also got a board where we've actually partially etched it, and the copper's been wearing thin because of all of the experimentation we've been doing. So we've got a good set of boards that we can use to create this solder mask. And how are we creating this solder mask, you may ask? Right, well, first things first, let's get the materials that we're going to be using out of the way, and then we can start looking at one, the application, and two, the exposure to create the mask itself. So you can actually buy solder mask material, and it comes in a variety of different colors, and it also comes in these syringes that we can use to apply. We only need a small amount. Here are the colors that I currently have available. I thought I had a green mask, but I have three colors. We have blue, we have white, and we have black. And essentially these are UV sensitive masks, right? It's a liquid. We pour it onto our circuit board and effectively expose it to UV light to cure it and make it a solid. Now, the problem with this is that we only want this to go solid on the areas that we want to protect. The areas where we're going to be soldering components, drilling holes, and just generally needing access to the copper, we don't want solder masks to be there. So that can be a little bit problematic when it comes to just putting this stuff onto a circuit board and exposing it to daylight, for example. If we did that, we would then need to use either a CNC to remove the material from the pads, or we would need to cover over the areas quite accurately so that the UV light doesn't get to that section. So we're going to be testing this. This stuff has been in my drawer for a little while now, the same as the UV coating that we used on the circuit board. So we're going to try and use this material. I'm going to use my trusty Anycubic Photon S 3D printer to expose this material and try and get it so that we get the pads available to be able to be soldered. So we're going to do some experimentation first, and we're going to try and figure out what the exposure time is for these liquid, it's more like a toothpaste, right? Sort of consistency. But we're going to need to figure out how long we need to expose this material for. Now, looking at the looking at the labels on here, I thought I just saw on one of them that it was only like a 10-second curing time. Here we go. So apparently, let's go to the overhead. Apparently, it cures in around about 10 seconds, right? So that all depends upon the wavelength of the UV light source and the strength of the UV light source. So we know that the UV film that we applied to the circuit board takes about 3 minutes to expose. It would be interesting to see how long it's going to take with this material, even if it's going to expose at all. There is a chance that this will not expose at all because the 3D printer's UV light source is not the correct wavelength to cure this material, which is why I've highlighted this stream as an experiment, because we don't quite know what the result is going to be. So, with that said, let's get some preparation work done so that we can get straight into testing. So let me see. The first thing that we're probably going to want to do is get a test file in place so that we can expose the UV coating in increments so that we know how long it actually takes to expose the whole unit. So we're going to jump into Fusion and we're going to create a file whereby we can upload to the 3D printer and then expose the mask as a test, right? And we'll have a series of increments. Let's jump over to Fusion. And in Fusion, we've got a fresh file here. We're going to save this file as solder mask calibration. Solder mask calibration. Okay, we'll save that. And what we're going to do is let's create a sketch. And we're going to pop a sketch on a default plane. And we are going to just put in a rectangle. And let's dimension this out. Let's make this, yeah, let's go 10 millimeters by 10 millimeters. Okay, perfect. So what we're going to need to do now is to create a pattern so that we can have a different value for each of these squares in terms of the length of time that we're going to expose it for. So let's go to our create section and go for a rectangular pattern. We're going to create, we're going to select the geometry that we want to pattern out, and we'll drag it out to the side, and we'll say we want, I don't know, let's say we want 5 of these. And let's change this in from extent to spacing. And let's go the same this way. Let's have, I don't know, now 3 is good. That's probably good enough. And we'll go in increments of 1 minute. So now we've got these squares. What we can do is put some text on here so that we can work out which one is which. So let's go to the create section and select text. And we're just going to pop a text box here. And we're just going to put the number 1 in. Let's make this, I don't know, 7 millimeters tall, so it'll fit within that 10 millimeter box. Click on OK. We should be able to just drag that roughly into the middle of the box. And all we need to do now is copy this, and we'll paste it into the drawing, and we will just pop them roughly in the center, and then we'll need to come back through and update each one of these until we have a unique reference for each one of these boxes. So I'll just quickly do that by just quickly just drag these out, and then what we'll do is we can then select the row of text like so. We copy it, paste it, and then we can just drag it down, and we've now got a complete row done. Perfect. All right. So now all we got to do is just come through here and just change this text. And I'll try and trundle through this as quickly as I can. We're going to just update this text so that we've got a unique reference in each one of these boxes, so that when we come to print each one of these, we will know which one is underexposed, which one's overexposed, etc. So like before, we've got a few variables that are in play here. The main one is the age of the material. It's been sat around for some time, like the UV coating that we put on the circuit boards when we etched it. So I don't know how well this is actually going to go. This could go horribly wrong, but that's the whole point of it being an experiment. You did it! Welcome in. I hate Fusion 360 so much. You do? You hate Fusion 360 so much, I renewed my subscription. Heard that. Once I get my plasma CNC built, it would be a game on with Fusion. Right. That's gonna be epic. I so want a CNC plasma. I mean, I want all the toys. Is that something you're building, or is that something you are purchasing? That's something and if so, if you're purchasing, which one are you going for? I'm not jealous at all, by the way. Yeah, I love these sorts of machines, and getting a CNC plasma is going to be a game changer in the sense that you're going to be able to work. You're going to be able to work on sheet steel material, and be able to, well, pretty much make anything you want. And that's partly the reason I got into digital fabrication. One is because my usage of hand tools sucks. But yeah, getting a 3D printer to print things, getting a laser cutter to cut things, getting a CNC machine to cut things, and then finally the plasma to cut like the heavy duty stuff. Oh man, I can't wait. I can't wait to see that, man. You bought all the material for it to build 4 foot by 8 foot. Nice. I'm loving that. You can go for now. The next question is going to be: how are you going to be able to manage a 10mm sheet of mild steel that's 8 foot by 4 foot by 8 foot? Right? You're gonna have fun with that, right? World Rally Race, welcome in. Yeah, I will do, man. I will do. So I've got a little. Since we're chatting here, I've got a little bit of an announcement to make. I have enabled channel memberships. So there are 3 different tiers for channel memberships that offer different levels of rewards. So the workshop and above gives access to the private Discord, and it also gives access to any project files that I create as part of my YouTube videos, and I'll make those available within that area. So if anybody wishes to support the stream, feel free to check out channel memberships. Shameless plug, but that's the life we lead these days, right? So here we are. We've now got a grid 5 by 3. We've got 15 squares. Each one of these squares is going to represent a minute in time. So we've got to figure out how long we're going to expose the model for, so I know how thick the layers need to be for each one of these to be able to expose it for the right time. No, it's not low ray. I'm not repeating that. You'll see on Insta how I struggled to lift this onto a storage cart. I had to get your garbo in combination with a ratchet stuff. Dude, you need to get like an engine hoist with an electromagnet or something like that. Now there's there's an idea, right? Huh. So we're going to use, as I mentioned earlier, we're using my Anycubic Photon S 3D printer, and I need to get this file into the printer. And to do that, I've gone and put my pen drive down somewhere. Oh, I spy it. I see it. Panic over. So what we're going to do is now we're going to figure out what height each one of these is to yield a minute's worth of exposure. Okay, so to do that, I need to go into my slicer. I'm going to put in an arbitrary primitive, and I'm going to go to my export settings, and I'm going to go to my fictitious resin that we're going to use. And we're going to go in here and edit it. Looking at this, we are saying it is 3 seconds per layer. And we're at 50 micron. So in order to yield 1 minute's worth of exposure, I need 30 layers. So that's 30 by 0.05 millimeters, if my math is right, which has the potential not to be right because my brain don't like braining when it comes to math, right? Anywho, right. So let's extrude this, and we'll do the math in the formula bar rather than typing in, because that's going to cause me a problem. So it is 60 layers divided by, is that right? Hang on. I think my math is wrong, actually, thinking about it. So 60 seconds divided by 3 second intervals is 20 layers. So it's 20 layers at 0.5. Oh, I'm glad I checked that. So 20 multiplied by 0.05 millimeters. Okay, so that should give me a 1 minute exposure time for this object. So you'll notice that the text hasn't come through. We've not cut that in, but we'll do that in a second. We'll do that as part of the next operation or the final operation. So we'll use that math calculation to extract this. So let me. How many layers is this going to be? In fact, let's build the formula complete, shall we? That way, I'm not going to get it wrong. Okay, so let's delete that. So 60 seconds. This is one thing I do like about Fusion, and a lot of CAD programs do this as well. 60 seconds divided by 3 seconds, right? Multiplied by 0.05 millimeters. Okay, so that's that. So if I just go back in here and edit this, I'm going to copy that formula. And we're really going to expose my math ability right about now. So in here, we're going to paste that. And instead of 60, it's 120. Okay, and we're going to do that again. So we're going to extrude that distance, put in our formula. Uh, 180. Extrude. This will be 240. Extrude. This will be 300. Okay, so that's our first row. So we just got to repeat this for the next batch. Okay, extrude. $360. Ah, yeah, this is where we're going to expose my math in, right? So first one was 360. This will be 420. That's right, isn't it? Yeah, 420. See, I probably made this more difficult for myself doing it this way, but this will be 480. Or 80. Oh. Don't edit a sketch, Steve. That's not what you're supposed to do. Oh, my word. My brain's dead. Okay, let's get this right. Okay, 540. Okay, and this will be 600. Oh, I selected the text. Don't do that. Don't select the text. We don't want to select the text. We want the box, not the text. There we go. Paste. 600. Do the easy ones now, right? Extrude. This is 900. Whoa, that's not right. There we go. It's a little bit better. You find the light of purple disturbing. All right, Mace Window. How you doing, Vex? Welcome in. Okay, so we got 660. $720. $780. One more. Okay, we've got one to check as well because I want to make sure I got these numbers right. Okay, this one is 840. Perfect. Let me just double check. Right, that one's correct. That one's correct. Okay, and number 8. I just want to double check 8 because I'm done like that. But it might look like I actually got it right. I stumbled through it, but I got it right. Hey, I got it right. Cool. Right. Finally, it does seem like a while, right? And I am well. Thank you for asking. Appreciate you, man. Okay, so now what we're going to do is we're going to extrude the numbers, right? Because it's the numbers that we're interested in. So let us hide the bodies for a moment. And then we're going to select, we're going to say extrude, and we're going to select each one of these numbers. And we're then going to extrude them through the cubes that we've made. And remember, each one of these cubes represents a minute in time. Okay, so let's bring the bodies back in now. We've selected it, and we're going to say the extent type, I'm going to change from distance to object, and I'm going to select the top of the tallest cube. And what we should see is that this is all calculated. Oh, it's saying it's failed. Okay, let's change this to distance then. Sometimes, I suppose we are cutting through multiple objects here, so that's probably where the problem comes. There we go. Let's get rid of the sketch a moment, and now we have these cubes with a number cut through the centers of them, right? What we've got to do now is we've got to export these as a STL file. So we'll select the root of the drawing, and we'll right click and we will say save as mesh. We'll click on OK, and we will pop that into my download folder. We'll say save. There we go. Done. Done, 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 done. Okay. So now let's go to our Litchi slicer, and we're going to import that file. Okay, let's get rid of the other files we got there. Let's go to our downloads, solder mask calibration, and there it is. There is our solder mask calibration, and it is in the center of our build plate. So just to talk about the setup for the printer. This technique is borrowed from Stephen Hawes' video, and you'll find the details of that in the description of this live. And he uses a Formlabs printer to expose a UV prepared circuit board with this material, right? It's a UV coated material. It's got protection on both sides. You put it onto a copper clad board such as this, and then you expose it using the 3D printer to create the circuit board. Now we have done that, and we have created this board, which you can already see is starting to mark up with corrosion and fingertip grease and all of that sort of stuff. So we've got to get the solder mask on here. Now, Stephen Hawes had to hack the Formlabs printer. He had to get root access to the printer using a secure shell. So he had to change some firmware options. He had to fake the printer having resin in it. And he had to do a bunch of complicated things to make this work out of, rather than it working out of the box. Whereas with the Anycubic Photon S, it's pretty dumb in the sense of, what it's capable of in terms of the measures and technology that's in it. It's quite an old printer, which is good for us. It's good in the sense that we don't have to hunt down how do you get access to the root of the device. How do you SSH into it? How do you change firmware options? I don't have to hack the printer. I can just use the printer as is, and we're good to go. So that's what we are going to be doing with this. So let's go back to our file and get this prepared. We'll grab our pen drive that we're going to be putting these files on. And let's pop that in. Now I've got a fictitious resin. And that fictitious resin is only there so I can set the exposure time for each layer. And let's take a quick look at that for a second. And we'll see that we've got... I've just realized something. This is going to be backwards. The text is going to be backwards. No problem. But it just suddenly dawned on me. So if I go into the resin, I've created this Aryan filler resin, and if we go into it, we say a number of burn-in layers. So the burn-in layers are there so that you adhere your model to the build plate, but we don't have that build plate in place. We've taken it out and we set it to 3 seconds exposure time, and it's 3 seconds for the remainder. So that's all we're using this fake resin for, is just so that we got a bit of control over how much time the light is on for the exposure. Now, you might ask, well, why don't I just turn the light on for a minute, make each layer, a minute long, and just leave it at that? Well, the reason for that is these machines are not intended to be turned on all the time. So there's quite a large heat sink, there's a fan on them, and it kind of keeps that pretty cool. Whereas if you keep the UV light on all the time, it is going to damage that light source, and we don't want to do that. Sammy! How you doing, buddy? Welcome in. Long time no speak. How you doing? Hope you're good. Yeah, Biggins is in here too. Uh-huh. All right, so let's turn the sharpen detail on. We're going to export the slice, and then we're going to throw that onto the pen drive. Now, this is the free version of Litchi Slicer. You can get a paid version of it, and that gives you access to their library. It is software as a service, so it's a subscription. But you do have access to the library of models, depending on which tier of the slicer that you get. For my needs, the free version is absolutely fine. All right, so we're going to save this as a solder mask calibration, and we're going to export that out. There it goes as we go through each of the minutes. This is going to take around about 15 minutes to expose, right? To get the whole thing done. It says it's only going to take 10 seconds, but I don't think it's going to. I think it's going to need longer than 10 seconds, right? Because this is not a high-powered light source. So, right, we've got that. Now we need to prepare the printer. So the first thing that we're going to use to protect the printer is a bit of cling film, right? So this is like a cooking wrap. In the US and Canada, I believe you probably call this saran wrap. We call it cling film. It's a film and it clings. Let's not overcomplicate things, dude. Oh, dude, thank you so much, Sammy. I've got to say, you are the first person to do a super chat. You are number one in that regard. Thank you so much. Appreciate you, buddy. You gotta love them cheeses. You've gotta love them cheeses. The question is what does Biggins have to say about the cheese? Huh? What does Biggins got to say about the cheese? The Savvies, thank you so much, man. Appreciate you. So we're going to use this saran wrap, and we're going to put the saran wrap over the screen because I'm expecting there to be some overspill when we apply this UV coating, right? And I don't want that getting on the screen. I don't want the cleanup hassle. If I can just take the saran wrap off or the cling film off, we could just, have a better day when it comes to cleanup. See, Biggins is kind of like, he's gone quiet. I think he's been repelled by the cheese. What do you think? Now, this saran wrap is a little bit difficult to work with in regard to the fact that it's sticky.
And I don't know how much you guys are seeing this, but we're going to try and just cut this down a little bit so that I can get this applied to the printer. Whoop, 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 come on, cut, cut, cut. So let's get this on the printer and let's see whether or not we can cover this screen in its entirety. And what we don't want is any sort of creases or bubbles or, you know, anything that can obscure the light. Like I say, all this is to do is to protect the screen. We may just have to roll with it with the wrinkles. Right now, I think that'll probably be okay. All right, so now we've got the Saran Wrap coating covering the screen almost fully. We need it fully. So let's just put that under a little bit of tension. There we go. That's better. That's better. So now we get our 3D printed jig, which I have no clue where I put. It was here earlier, and I've been an absolute tool. Here we go. Here it is. Here's our jig. And let's just pop this into place. All right. All right, let's put our spacer in place because we need our spacer just here. And now we're good to go to prepare. Yeah, dude. Yeah. Yeah, you could very well be eating nachos. I think you might be. So, Savvy dropped the super chat. Okay, so we're going to cut a piece of clear material. This is not perfect, as you can see, but I'm not overly bothered as long as we get it justified in the one corner. Right, so we're going to use our failed attempt, which I believe is this one. All right, so you guys get to choose which color solder mask we're going to go for. I'm not going to use the black because I reckon that's probably going to be problematic in terms of light exposure. I mean, theoretically, it shouldn't be, but I want to give this the best chance of success. So you've got a choice. We either use the blue or the white solder mask. Which one do we want to use, guys? So we have, and here's me being a complete fool, not using the right. So I've just cut a piece of clear material, which we're going to put over and make a sandwich with either the blue or the white solder mask. Did I drop that solder mask? Where's it gone? There should be a tube of white here somewhere. So there's the black, there's the blue. Where's the white gone? You guys are all going to say, use the white, aren't you? Now it's in front of me, like, duh. So we're going to be using either the white or the blue solder mask. Which ones do we want to go for? I'm going to give you guys... Dude, I'm being a complete dumbass, right? That's another super chat. Dude, thank you so much. I saw, do you know what? I saw the little logo, the little emoji, and I didn't pay. I'm new to all of this. But dude, thank you so much. Appreciate you. So let's glove up because we don't want this. We don't want this UV stuff getting on my hands. It's probably like a health hazard, right? So give this an attempt, and we're going to get to see how well this is going to expose. So, Savi, just to give you a heads up, I've only just got to a point where I can turn on memberships for the channel. So that's how new in the game I am for like the super chats and all of that sort of good stuff. I'm sure I'll get better. So apologies for missing that second one, dude. Okay, so I'm going to use my 3D printed plunger to apply the solder mask. I currently use that for my flux paste. Let's put that back in my soldering drawer. Okay, I'm going to go with blue. This doesn't seem to be a particular preference, so I'm going to go blue. And all we do is pop the syringe in and tighten the plunger down. I noticed Biggins didn't say if he was enjoying his nachos, though. Okay, so what we're going to do is we're going to put a blob of this material right in the middle, right? There's a decent amount. Back that off, and then we're going to put the lid back on. Now, you've got to keep this stuff in a light-proof bag, because when it gets exposed to UV, it solidifies and turns solid. There's no daylight and there's no obvious UV light source right now, so I've got no issues just bringing this out. So what I'm going to try and do is put that in the center, and then I'm going to put this down, and then I'm going to squish the solder mask. And I think, if I remember correctly, I've got a squeegee here. Oh yeah, I got a squeegee. I'm going to squeegee this around the circuit board to see whether or not we can get like an even coating across the board. Now, in theory, I should have cleaned this, but because this is just a test article, I'm not overly worried about you know, how good the surface of the copper is. When we do this for real, when we do this in anger, then we will clean the board up. But yeah, so I'm in the game, dude. I'm in the game. We're making some progress and gains on the YouTube front, and I'm really pleased with the level of support that I'm getting just right now, just in people watching the videos and the lives. I'm definitely feeling blessed. I think Biggins is busy. Okay, so I want to see if I can just get an even coating. All right, now did I get any? No, I didn't get any of this resin on here. All right, so there we go. We've got a sample. I'm hoping that's big enough, right, for the area. So we're going to put this in the printer now. We're going to justify the edge. I'm going to wipe this down because I don't want the UV mask to get everywhere. I only want it in the places that I want it, right? So as you can see, it's mucky stuff, right? And this is one of the reasons why you would get these boards made by a circuit board manufacturing company. Okay. I think we're good. And this is why I put the saran wrap. This is why I put the saran wrap onto the printer, because I got a funny feeling this is going to leak out. And I'd rather it leak out onto the saran wrap than onto my printer. So we're doing a bit of protection work, right? Okay, so here we go. Let's get this on and justified correctly. Let's get that like so. And we're going to pop this down, face down, on the saran wrap, in the corner, like so. Okay, perfect. Now I've got to power up the printer, and we're going to run the print job. And that's going to take about 15 minutes to run. And then we're going to come back and inspect to see how much of our UV resin has cured. And where's the sweet spot? Where is the sweet spot for us to benchmark how we're going to do this for real? So right now, all we're doing is trying to figure out how to do this on a real circuit board. All right, let's plug in our pen drive into the printer. Now this is going to make I've got to do a bit of maintenance on this, right? So this is probably, I don't know if the noise cancelling is going to get rid of this, but fingers crossed it will. Right, so we're selecting the solder mask, and then we're going to hit print. So yeah, I need to get some lubrication for the lead screw. It may or may not make a noise here. So we don't want this overexposed. We don't want this underexposed. We want to try and find that sweet spot. And I'm hoping that sweet spot sits somewhere from 1 to 5 minutes. Sorry, 1 to 15 minutes. So that is now on its way. So we will leave that to work its magic. And while it's doing that, we can have a chat. If anyone's got any questions about what we're doing, why we're doing it, feel free to ask away. Now, what we're doing is we're making a breakout circuit board to interface with a piece of equipment and experiment with it. We're not quite sure how it works, so I'm making some hardware interfaces into this device so we can play around and figure out how this thing actually works. so that I can make a professional board that can control all of these bits and pieces of the unit. And I can't say too much because it's a friend project. Now, we're using a method that Stephen Hawes recently showcased. Stephen Hawes is one of the founding members of Oppulo. Oppulo is an open source company that makes the Lumen PMP, and that's the pick and place machine that I also did a video / live stream on building that. So I've got the Lumen PMP just behind me here. He used a Formlabs resin-based printer to expose a piece of UV coating which he applied to a circuit board. Now, we did this, and we successfully got a working circuit board. This is the interface board that we made. Try and get that in. Oh, there you go. There we go. The lights are playing with us a little bit. So this is the board that we're making. And as you can see, there's a little bit of discoloration on this board because it's been open to the elements. One thing Stephen Hawes didn't do was to apply a solder mask. And that's what we're doing in this live stream. We're applying a solder mask to the circuit board that we have made. So the next thing that we have to do is prepare the mask. Instead of using the test file, we're going to need to use the circuit and the mask that we had created in that. So let's bring up that file. I should have that available to us. Let me just pop this out. Did I import the mask? Okay, let's quickly hide the bodies. Okay, cool. Let's bring this onto the scene so you can see it. So here's the circuit board that we brought in. That's the traces. And then we did the perimeter, and then we did what? Please tell me this is the solder mask. Please tell me this is the solder mask. Come on. Yeah, we got the solder mask. Sweet. All right, so what we're going to do is we are going to include the board cutout. And what we're going to do is we're going to extrude this to create our mask. Ah, okay, I see what's going on here. All right, we're going to have to do this in 2 operations. So we're going to extrude this by, I don't know, let's just say 1 millimeter. We don't know what the thickness is just yet. And now if we hide this body, and then we're going to select the solder. We're going to select the pads. So these are the things we're going to use to solder the components into place. So that's the main ones. I wonder, can I just do that? I'm hoping I can. Oh well, I'll just have to select them individually. I'll quickly do this. Now, the reason this is lagging is because there is a lot of geometry in these circles. With normal sort of Fusion 360 files, these circles would be vectors. And these have been exported from KiCAD. And the circles are made up of lots and lots and lots of little straight lines, meaning that there's a lot of geometry that's in here, which is a little bit unfortunate, but that's how KiCAD works. So we just got to live with it for now. All right, so now we've selected all of the pads. Let's bring back in the body, and then we're going to say we're going to extrude. And this is gonna struggle a little bit, just simply because of the amount of geometry that's in here. Sounds a little bit counterintuitive because it's a very simple drawing that we've got. We'll go to object, to the top surface here, like so. It's thinking. That black line, oh, I hate seeing that black bar here. That's a bad thing that happened in Fusion. That typically means that Fusion 360 is having a bit of a moment. And right now it's trying to calculate all of those little, like hundreds of little lines per circle. How it is trying to figure out, oh, I gotta punch through here. So it's doing a lot of math right now. And you can see, there we go. If I click on OK. TikTok, come on. Do it, do it. See, it's compute started down here in the bottom corner. It's now calculating all of that. And we'll inspect the hole that it actually produces. You can kind of see it on this bottom edge, just here. Instead of around the corner, you can see like all these vertical lines. But that's just the nature of what it is we're working with right now. Right, let me just quickly check in on the printer. It still thinks it's printing, right? So we've got rid of, let's have a look. We've got rid of two of the squares. I'm just hoping one of the squares has successfully cured as part of this process. But we shall see. That's why it's an experiment. Because we don't quite know what's going to happen. Is it either going to work incredibly well, or it's going to be an absolute pain? If the etching is anything to go by, it's going to be an absolute pain. But there we go. All right, so we've now got our. This is our representation of our solder mask. So anywhere where we've got solid body, that's where it's going to cure, and the pads will not cure because there's no material on them. But if we come into the circle in here, you see all of these little pieces of geometry, right? That just had to work through. It's a little bit of a shame. Maybe KiCAD can get its act together, and when it produces these files, I mean, it could be a limitation of DXFs because this is a DXF export. So it's potentially a limitation of that. But maybe I need to investigate a way that we could possibly get this to have nice round circles. We'll see. We'll see. All right, so we won't know 100% what's going to happen in terms of the exposure time until we get the output of our board. So that's going to have to run until completion. Let's just talk about the method that we're using to produce this board. We're using a
UV resin printer to expose a UV sensitive material to either leave behind a trace, a circuit board, or to leave behind our solder mask. One of the things that that I would not use this for, I would definitely use this for very simple circuits, very primitive circuits, but I wouldn't use it for something like this, which is quite a... This board is, if I can get it in focus, this board is quite a complicated board. It houses a ESP32 microcontroller. We have a LiPo battery connector, and we have a bunch of circuitry for charging. We have a bunch of circuitry for two different display types, one being an e-ink display and another being an LCD display. So this is a 4-layer circuit board, and yeah, the traces are really, really fine, and they will probably not be able to survive the acid bath that we put the other board through. That's partly the reason that the traces on this board are quite thick. It's not because they're going to be carrying high current or anything like that. They're that thick because I wanted to make sure that the traces survived the process. Now, as I understand it, the professionals, the way that they make circuit boards, they get the substrate, usually an FR4 fiberglass board. It's the base layer. It's also known as the substrate. And then they will put a coating on representing the circuit board, and it goes into a dip, and it deposits the copper. So where in this case, we remove the copper, in this case, it's more than likely deposited, actually place the copper on. Now, with a multi-layer board, what's likely to happen is that they do this in very fine layers and then they bond it all together. And that's way, way, way above my skill level as an amateur circuit maker to be able to pull this together. So with something like this, whether it is something like this, which is my control board, I would look to have these professionally made as opposed to making something at home. So why would you do this? Why would you make a circuit board at home yourself? Well, there's a couple of reasons. One is the turnaround time. If you need a prototype to complete a proof of concept, and you need it in hours, not like days or weeks, then you're going to want to use this method. The second is that for like a proof of concept, you only want a single board, more often than not. With the circuit manufacturers, you are looking at a minimum of 5 boards. So you use your proof of concept, and it fails, you've now got 5 boards which are toast. If it works, you've got 4 boards which are toast, because it was a proof of concept. You're not necessarily going to use that. You're going to advance your design beyond. So doing it this way, either using a CNC machine to mill the traces out, or using the method that we're using and etching the copper, is another good option. So we need to figure out, as I say, we need to figure out a few things to make this a little bit better. I do have a use case specifically for the Lumen PNP. There's a couple of circuit boards that I realistically need, and I kind of hacked it using a 3D print and some copper wire, enameled magnet wire, which kind of works, but kind of doesn't. So I'm gonna probably, once I've done this, I'm probably gonna look to prove out that it actually will
be able to make a smaller board. Now, while we're waiting for that, I'm going to prepare this board. I'm going to try and use a brass brush. I might need to pop down to the workshop outside to get some steel wool to clean the board up. But yeah, we're gonna need to figure out, is that the successful figure? That is the success, I believe. It is the success. Let me see, what else have we got? Yeah, I don't have any steel wool up here, but I do have some brass brushes, which may or may not work. Okay, I'm gonna leave you with the printer a minute, and I'm gonna quickly nip downstairs and get some steel wool, and I will come back and we'll clean this board up. One moment, I will be back. Alrighty, okie dokie. So let's go here. Just slim down the amount of steel wool that we're going to use. And all I'm going to do is just come through here and polish up these copper traces with the steel wool. They're nice and shiny. Shiny. All right. So that's made a significant difference to the look of that circuit board now. Okay, so what we're going to do is twofold. I'm going to just go here, and we're going to get some magnet And we're going to clean up all of the metal that's been left behind by using this steel wool. Look at that. Look at the fuzz that's picked up. All right, let's get that in the trash and away from electronics. All right, let's do that again. And that's going to be the beauty. If I can get myself a bit of a workspace where I can do clean and dirty work, you know, separated, get a clean room and a dirty area, that would be kind of like my goal. But I think I'm a little ways off that. But we shall see. We shall see. All right. So now we've done that, let's get a bit of IPA. And we'll give this board a bit of a cleanup. Just to get any fingerprints. Just need to be a bit sensitive with handling this now. And you can see the dirt that's just like taken off. All right. And just clean up the bench where it's left some bits and pieces behind. And we'll put this to the side. Be very careful not to touch that copper now. And where are we at? Okay, so we're 120. We are 120 layers into 300. So that's just working away, just exposing that board. All right. So, with that in mind, does anybody have any questions around what we're doing, or anything else of that matter? If anybody's got any questions about anything, we can go through that. No problem. All right, let's just bring up. So yeah, we're waiting on this to complete. So while we're waiting for it, we can possibly look at some upcoming projects that I've got in mind. So one of the upcoming projects will be to redesign this board here. So this board is a 4-channel light controller. It works off Home Assistant, and it uses an ESP8266. And I'm essentially building it so that I can control my studio lights and untether them from the setup that I've got currently. At the moment, these lights are... Let me just go here. So at the moment, these lights are currently hooked up to sockets which I've mounted up on the ceiling. And that essentially means that I've got cables hanging from the ceiling. And ideally, I'd like to train the cables down to a socket somewhere and be able to control the lights independently of the things that they're plugged into. So for example, if I was to take these to the outside studio, I would like to be able to control them from down there and not have to have any sort of special any special setup for that. There we go. Getting a display pop up. So yeah, ultimately, that's one of the things that I'll be working on. I will be probably doing a little bit more work on this board. This board, as I say, is a multi-function board, and it drives these badges. This is an e-ink badge, and ultimately you can upload images to this. So if you're at a convention, or if you're at a meeting of some description, right, you can pop one of these on and have all your social media bits and pieces. There's that module, and there's also this one, which is an LCD version of it. So yeah, there's two versions of those. So I'll be working on those. I've got some laser cutting projects that I'll be working on, where I'll be restoring a brand named laser cutter. And there's also the CNC machine build. So I'll be building a CNC machine from scratch, because I am making a bass guitar for my youngest son. And one of the things that's holding me back right now is the limitation of the CNC machine's bed or cutting area, working area. So, I mean, I would love to say that I had the funds to be able to buy a brand named CNC machine and just get on with the job. But I'm having to take the more difficult route. It is less it is less expensive in monetary terms, in in terms of time and effort. Yeah, I'll be building a CNC machine from scratch. So yeah, wish me luck on that front. Like, where are we up to with this? We're up to 149. We're coming up to about halfway on this print. Do you know, I'm wondering how long has this been? This has been longer than 15 minutes. Have I completely messed up my calculations here? It should only be 15 minutes. What is the slicer? Slice is telling us it's going to be 25 minutes to complete that in total. So have I been a doofus and completely messed up my calculations? Let's work this out, shall we? Let's see if I've made a mistake. Right, let's go to our solder mask calibration. Let's first of all save that file. And let's go to the tallest one, and we'll work out how tall this is. And then we'll work out how many layers it is. So if I inspect, okay, that's 15 millimeters tall. So let's do the math on this. So 15 millimeters divided by 0.05 is equal to 300 layers. 300 layers multiplied by 3 seconds per exposure per layer is equal to 900. Divide that by 60 to give us minutes, and that's 15 minutes. So that is right. That is correct. So I guess what we haven't factored in is the printer's the printer is thinking, because it's exposing, it's got a lift to let the resin flow in to underneath and then drop. So I think that's playing a role here. So let's just quickly take a look. This is going to be such an anticlimax if this doesn't work, right?
if this doesn't expose at all, this really is going to suck. Let's get a shout out in chat. How many of you guys actually think that this is going to work versus how many of you think it's not going to work? Keen to get that from you guys. And that's where chat delay always kicks in. Got to keep talking. So this, as I say, could be a very unproductive sort of scenario. That would be the worst case scenario, is that all of this is for naught, and the cure time of this UV mask is in excess of 15 minutes based upon the wavelength that the UV light has and its power. Those are the two variables which will mean when this will either work or it will fail. We know it should work because in principle, because we've been able to expose the circuit board and do all the good stuff with that. So in principle, it should work, but practice is another matter. So we shall see. We shall see. Where are we up to? Okay. Got another 130 layers to go. So I think what we'll do is talk about some of the, as I say, I mentioned some of the projects earlier. Let's have a look at the CNC machine, shall we? Let's open this up. So this is the CNC machine that I'm looking at building. And I mean, there's a couple of different ways I could go down the road of this. Oh, there's lots of this turned off. Why have I turned it off? Okay, here we go. So we've got a gantry in here. Let's have a look. Why is that? I am missing. I'm missing quite a bit here. Where's that gone in my? Aha, there it is. Okay, let's switch this all on and you can see it in all its glory. So this is the CNC machine that I am putting together. And right now I'm trying to figure out how I'm going to connect sort of these end pieces, the motors, and all of that sort of good stuff in a way that is consistent, is modular. Likely that I'm going to be making my own brackets or have them made for me. Where is that bracket? I want to switch the others on. It's in the frame section, is it? The bodies. Aha, there we go. So there's the front brackets. And the idea being is this is going to be able to This is going to be able to drive my CNC workflow for the bass guitar. Being able to cut the neck in one piece is going to be a big deal for me, and getting that project moving forward. But yeah, there's a few constraints, time constraints, money constraints that have prevented me from progressing this at the moment. But it is what it is. It is what it is, as they say. So just need to push through the pain barrier and get to the other side, and hopefully it will be worth it. So that's that particular project. All right. All made on Fusion 360, the free version. So, you know, if anyone says that the Fusion 360's free version isn't capable, well, I beg to differ. I would say it's probably useful for the vast majority of makers. Yes, there are some features that would be nice to have that are in the paid version. And yeah, if I had the workflow and I was selling the things that I was making, I probably would go for the paid version. But for right now, it's a good showcase for makers, new people coming into the digital fabrication side of things. I mean, Fusion 360 is really good in the sense that it drives the 3 workflows, possibly 4 workflows that I'm going to be getting involved in, which is 3D printing, laser cutting, and CNC milling. Now, theoretically, we could also translate that into CNC plasma. So if I do go down the plasma route, the designs that I can build in here will serve me well, in the sense that I can use Fusion 360 to continue to work on those workflows. And I'm only learning one tool, right? I haven't used Fusion 360's PCB functionality. You can actually make circuit boards in here. And the reason I haven't is predominantly because I do have the intention of selling the circuit boards, designs and products that I make with the circuit boards in the future. So I don't want to be stung by the the constraints around the personal license, and using open source software like KiCAD enables me to, you know, free myself from that burden until such time as I get a paid license for Fusion. And if I get a paid license, then, you know, it's a bit of a moot point then, and you can kind of have everything integrated. You can bring your circuit board into your design, you can design the enclosures around it and all of that sort of good stuff. So that essentially is where I'm heading with that. Okay, so where are we up to now? 208. So we're less than 100. We're less than 100 exposures away from completion. Now I will need, so when we get this dialed in, I am going to need to replicate the conditions that we use for creating this calibration. So that is the cling film or saran wrap on the screen to protect any UV solder mask getting down onto the screen. There is a I don't know if it's PVC. There's a PVC sort of sheet that we're using to create the sandwich between the board and we're going to sandwich the solder mask itself. And I would argue to some extent the color of the UV mask that we apply could potentially be a factor as well. So for example, the white UV solder mask might have a different cure time to the blue, which might have a completely different cure time to the black. It's interesting that the white has a
a statement of 10 seconds for cure time. The black one doesn't, that I can see, and nor does the blue. Okay, so interestingly, this one has got like a serial of UV, some presumably Chinese writing 10. This one has got UVH 900, so about a 900-second cure time, maybe? As this one also has 900. So, if that bears fruit, I don't know if you can, I'll hold this up to the camera, I don't know how well that's coming out. So you can see this, UVH 900, as same as this one, UVH 900, but the white as, come on, focus camera. Come on, camera, you got one job. You got one job. There we go. UV 10, and I don't know what this Chinese writing refers to. So it's a slightly different label on this one than, well, actually, no, it's UVH 900 as well. There. So maybe, well, that kind of puts the kibosh on that idea. I was hoping that it was going to say it was like 900 seconds, and the 15-minute exposure time is going to be what it is going to take to get that down and done. So there's four squares left? Let's have a quick look. Yeah, there's 4 squares remaining. And how many? We got 75 layers to go, so we're almost at the end. We're almost at the end. And then we can put the gloves back on, and then we're going to clean this up and find out once and for all whether or not we have a cured solder mask square. So I'm not expecting all of these to be exposed and cured, but I'm hoping one of them is going to be, and that'll give us the time exposure that we need for the actual run. So here, looking at the slicer, I mentioned before that this is going to be backwards, and the reason it's going to be backwards is because if you look at this, this is how the text will read if it was stuck to the build plate. If we were actually 3D printing something, right, you would see these little squares, these little stepping stones, right, with the numbers right through them. As it is, we are not looking at this in this orientation. We're looking at it, if I can rotate it, in this orientation. This is what we're going to get. Let me get this. Come on, turn around. There we go. There we go. This we're looking at it in this orientation. So when we remove the circuit board from the platter, we're going to have these numbers backwards, is my understanding. We'll challenge that. Because I suppose, actually thinking about it, maybe it is the right way. See, this is where it bends my head, because the build plate is upside down by comparison to a regular 3D printer, and that's what's baking my noodle. But we'll figure it out. That's why we are experimenting. That is exactly why we're experimenting, to figure out how this works, so that when we try to use this in anger, it does the thing that we need it to. So for anyone just joining us, we are doing an experiment where we are trying to apply a solder mask to a custom-made circuit board. That solder mask is a liquid that is applied to a bare board, and we're using the Anycubic Photon S 3D printer to expose the and cure
this solder mask. Right now, we're running a calibration test. This calibration test is intended to find out how much time we need to expose the mask on the printer to get a successful cure. Right now, we have 15 test squares. Each of them is numbered, and they reference the amount of exposure time in minutes that they have had through this process. So we'll be looking at each of these to find out which one looks the best, if any of them do. It is totally possible that we do not have a successful cure. We might get the isopropyl alcohol and clean this board up, and all of the solder mask might come off. And the reason for that is that there's a couple of variables that are at play. The first variable that is at play is the UV light source in the 3D printer. That light source wavelength may not be compatible with the solder mask that we are using, and effectively, you may not, as far as the UV mask is concerned, it didn't get exposed at all, and it doesn't turn into a solid. The second variable that we've got at play is the power output of that light source. So if it is a wavelength that can cure, it may not be at a suitable power to cure, meaning it's going to take longer for this to actually cure. So that's why we have these. These cubes, so that we expose it for between 1 and 15 minutes, hoping to find one that it perfectly exposes the mask and allows us to apply that calibration to when we're actually running this in anger against the real circuit board. So worst case scenario is that we actually cure over the pads that we're going to be wanting to solder to, and that's not going to be great, but it's not going to be the end of the world either. I can probably come in with a rotary tool and clean those out, very much like a CNC machine would have done had we done this process on a CNC machine. And I've never really attempted this with a CNC machine, simply because the precision that you need to be able to machine and mill the material from the pads, I don't believe I have that precision, and it will probably destroy the pads. I mean, maybe that's something we can try in the future. I certainly milled circuit boards on a CNC, as this board contests to. This is an ESP32 board, and it's actually a double-sided board. So this is a two-sided operation, and it worked, surprisingly well. So it is possible to do it on a CNC, but I wanted to test out this technique. I find it interesting, especially it takes me back to the roots of when I first started doing circuit boards in high school, and we would use the ferric chloride to etch away at the copper, and that's the process that we've used to make this circuit board that is essentially going to be our final target for this experiment. So we are getting towards the end of the process. Let's have a look. We've got 2 cubes remaining. We have, what are we? We got 35 layers to go of 300. So, and that's going down all the time as the machine is working away. So fingers crossed, we'll have that done very shortly, and then we can have a look to find out whether or not we've got a sweet spot. So there's two things here, right? So the first thing is, if this doesn't work, we'll do a summary, a wrap-up of where we're at, and
I'll go again off stream, and I'll hone it in, try and find out where my lurking variables are. But if it's successful, we could potentially go on and actually attempt to apply the solder mask itself and see how successful we are. And the kicker here is we're going to need to make sure we get this justified correctly. So the machine has been moved, the jig has been moved. So hopefully I've put the jig back in the right place. So when I apply the circuit board in the correct orientation, we actually get the mask applied to where we want it. Lots of variables at play. All for a prototype circuit board that's going to get used for maybe a couple of days and then crashed. It is what it is. It is what it is. Okay, where are we up to? 275, 91% complete. So we are getting there. So how many of you in chat have actually made a circuit board? And if you have, what method did you use? Did you use the acid etch method? Did you use CNC? Or did you use a board manufacturer? And feel free to leave your thoughts on, your experience using that particular method. And if you're watching this in the VOD, feel free to comment below as well. What method have you used to make circuit boards, and how was that experience? Was it a good experience? Was it a bad experience? Okay. I guess this is a little bit of a waiting game right now until this last silent mode. How you doing, buddy? Welcome in. How you doing? Good to see you. So we're continuing the experiments with the circuit boards. So you've first used, you first made a PCB using the acid etch kit, and you were nervous as heck. How did it turn out? How did you, there's so many questions I've got, right? So first and foremost, why were you nervous? Once you've answered that, the second question is, how did it turn out? Okay, we're up to 287. We're on the last cube, the final part. The final part. I'm going to have to find out whether it is a lower latency chat option. It'd be cool if we could get near real-time chat, but you were very concerned about the skin contact and the acid, as well as making a mess. Yeah, so ferric chloride isn't nice stuff. So whenever you handle chemicals that are corrosive, you should always wear gloves, eye protection, and if required for that particular material, a respirator, right? Because corrosive vapors in your lungs isn't good. So always follow the safety instructions for the material that you use. Secondly, around making a mess, ferric chloride is an absolute pain in the butt. It is yellow. If you've ever used turmeric, the spice,
Turmeric stains like nobody's business, as does ferric chloride. Ferric chloride stains things yellow, and if you get it on your hands, on your skin, you can wash. If you ever get any corrosive, whether it's acid or base, acid or alkaline, the vast majority of cases you can dilute that in water. There are exceptions to that, like sodium. Don't put sodium metal in water, right? You've got to put that in oil, right? But you can dilute sodium hydroxide. You can dilute ferric chloride. You can dilute that in water, plain tap water, and as long as you get to it quickly, you don't typically do too much damage to the surface of your skin. You don't really want to be in contact with that stuff very frequently. But the stains it leaves behind, they last for ages. You have to wait for your skin to grow out the stains. It's like, seriously. So yeah, that's ferric chloride is not nice stuff. The board turned out well, though. Yeah, it's quite an effective method for creating circuits. One thing that I have found in my time using ferric chloride is that it doesn't do well with thin traces. It'll burn through thin traces regardless of how well you mask things off, which is partly the reason that the circuit board that we've made here has traces that are as thick as they are. They're quite chunky. They're chunkier than they need to be because these are only signal wires that we're interfacing with here. They definitely don't need to be that thick. Looking at the thickness of these wires, we could probably take a good couple of amps through these at higher voltages than like logic, 3.3 or 5 volts, right? So that's not a huge concern for me. Oh, we're done. I start to glove up as I'm chatting away here. So the reason that those are as thick as they are is so that they add the survival chance going through the acid etch process. All right, so let's glove up, because the chemicals that we're using, the UV solder mask is a UV curing resin, very much like that used in 3D printers. So you don't want this stuff coming in contact with your skin. If you can at all, avoid it. So we'll glove up and we will get to removing this. And we're going to find out whether or not we've got anything in here usable. Okay, I can immediately see there's darker patches. So let's hold this up to the camera here. I don't know if you can make out these blotches. I have a suspicion that these blotches are the squares. So when I peel this off, we are going to see some uncured resin, right? That's going to happen. So the question is do we get some of these squares or any of these squares in a position where they are usable? So what I'm going to do is I'm just going to get some tissue here. We're going to mop this up as best we can with some tissue, and I'm conscious of spreading and making a heck of a mess right now. So I'm going to just dot these big bits of tissue here around my bench so that I can just pick it up, and there we go. We can already see. Okay. Well, that is encouraging. That is encouraging right there.
Ooh. Okay. So let's go with some IPA straight out of the gates. I'm excited for this, and we have the numbers round the right way, because unlike my first thought, this is actually a representation of the build platform, right? So let's see what we get. Okay.
So we have a result.
And the result is that we've overexposed it. Right from the get-go, we've overexposed it. Which to me is a good thing. In fact, it's a very good thing. All right, that looks like that's done for. Right, I've got UV resin on my hands, on my gloves, on my gloved hands. Let's be clear about that.
So yeah, that's the result.
That means even at 1 minute, we've overexposed the mask, which I'm pleased about. The question is, can I remove this mask at all from the board now we've got it on there? The ideal answer is no, right? But
okay, so yeah, we've overexposed that. Number 2 is probably the closest. I can see if I get it in the right light. Let's see if I can get this in the right light for you. Can you guys make out? Ah, there we go. Look at that. You can see the numbers that are there, but the bleed through has essentially overexposed the board. This is a really positive result, because it means that even though we've got saran wrap, even though we've got this PVC, we've been successful in curing the resin. So I guess now it's a case of figuring out, okay, do we do this again, but in increments of 10 seconds? So 10, 20. So we need 6 squares, and we've got to figure out the exposure time for 10 seconds. That's pretty cool. I like that. Question is can I remove it with some wire wool, steel wool? And the answer, oh, hello. Oh, hello. This is interesting. Right, so it will come off. Probably because it's not fully cured. And we probably need to put this under
a UV lamp to fully get it. This is very interesting to me. So I'm trying to remove the UV mask. So we've lost the mask 1 to 5. Okay, we're losing the mask entirely. So we can actually remove the mask with steel wool. Looking at the dust that I'm generating, I probably should be wearing a mask of some kind, a dust mask at the very minimum. Okay, I'm really encouraged by this. So we know that the exposure time is going to be sub 1 minute. So I'm gonna try this again. And this time, I'm gonna try it in 10-second increments, up to 1 minute. And we should hopefully get a decent result of it this time. Okay, so now we've got all this dust everywhere. Let's try not to disturb it too much and get this. Yeah, I did an IPA wipe. So when I was cleaning it, the first thing I did was to wipe it with IPA. Okay, that's toast. So the PVC that we used is a one-time use. So it's cured, and you've got to use quite an aggressive abrasive to get that to there we go. Let's just clean that up. Okay, we're going to go once more. Once more, dear friends, once more. So yeah, the IPA diluted some of it. The uncured stuff, but the cured stuff, not so much. Okay, so do you know what? I'm tempted, because this is a circuit board that's like it's dead, right? It's not going to be used. But what I think we might be able to do is to actually try and apply a real solder mask to it. And I'm going to shoot for a little bit of a mid-ground. This could be a silly idea, right? It could be a silly idea in the sense of I should get a decent calibration, a proper calibration, before trying to expose this with a solder mask of any kind, right? But I think I'm willing to give it a shot. I think 30 seconds could very well be a good middle ground for us to expose enough that when we come back through with some IPA, we'll remove an uncured material. Okay, let's just quickly look at this. Okay, so that's the bottom corner. Sweet. All right. So let's put some dang. Let's put some solder mask on here. Alrighty, let's put that down on top, and now let's use a squeegee to just manipulate that around the board. With the idea being that we get good coverage. We might need to put some more on here. I want good coverage over the entirety of the board. We're going to pretend that we're doing this for real, right? This time we're thinking, we've got the mindset of, right, we're actually going to do this. So right now we've got the circuit board. We want to cover all of these tracks with the blue goo. And try and get a consistent coverage across the board. Yeah, got to work on my application, I think. All right, so let's just give that a wipe. Doesn't have to be perfect. Good is good enough, right? Don't let perfection be the thief of completion. Is that the saying? It's something like that. All right, so we've got a so-so application of it. There's a couple of spots that are a little bit light. See if we can fill those in. I'd like to try and get as consistent of an application as possible. I suppose screen printing. This is where other mediums of artwork, right, could potentially help us here. Screen printing could be an option. If you've got access to screen printing materials, you could possibly make your solder mask that way. I don't. Maybe that's something that we could investigate later. Now, the application of this solder mask material is going to be critical to how successful this is. So whatever I do here, right, is just a test, and I need to learn. In fact, I'm going to purposely leave some dry spots, right, and I want to see what that actually means for the cure, right? Does it cure properly? Does it cause us a problem that we need to fix? All of that sort of stuff, right? So let's just make sure we're clear of all this crud. And then we're going to go and load this in the printer. Okay. So we're using the same, going to use the same method. So we're going to pop this in. We're going to just get it over to that side. Like that. Perfect. All right, so now we've got to get our resin, our solder mask model, and we're going to have to output that. So let's go here. Okay, first thing we're going to do is going to get rid of that. So that needs to go bye-bye. Get rid of you. Delete. Okay, so we're going to shortcut this process a little bit because we know we're only going to do 30 seconds exposure. And that still may be too much, but we'll see, right? So let's get our solder mask. Boop. That's the calibration. Boop. There's our solder mask, right? So if I right-click this and I save as mesh, where are we? Save as mesh. Boop. There we go. That's the one. And we'll click OK. And we'll say mask. Call this mask. And let us go. We're going to save it in downloads. We'll save that. Okay. Now, that's having a good old thinky think. We're going to add the file. There's the mask. Okay, so now this is a bit of a quandary for us, right? We've got to flip this over. So we know from the last time we have to rotate it. So if we go to arrange, right, let's select it, arrange or move. Where are you? Where's the on plate option? On plate. There we go. So I'm going to now what's going on here? Okay. Okay. This is not behaving the way I anticipated. Object to plate. There we go. There we go. That's what I wanted. Whew. That was starting to bake my noodle then for a moment. Okay, so let's go to the export and we're going to choose our fictitious resin. We're going to edit it and we know we're going to go for 30 seconds. So let's put in the burn-in layer as 30 seconds. And then when it does that first layer and is completed, we'll cancel the print. And then we'll take it off and we'll see how it's exposed, right? So let's go OK. We'll export. Oh, no, we don't. We don't export that. We're exporting the resin. Silly boy. Right, okay. We want our pen drive from the printer. Let's pop that in there like so. Alrighty, there it is. And now we say export to file. Now, we just got to wait for the... I really should pay for this just to get rid of the ads, right? But, I mean, I don't necessarily need to because it does do what I need it to. Okay, and continue. And we'll leave it called mask. We'll say save. There it goes. All right, 2 minutes and 7 seconds apparently. So what I'm going to do, I'm going to just quickly run this without the board on because I want to make sure that this is orientated correctly. So let's take off the board a second. And I'm going to say return. I'm going to say print, board, print. And we'll just let this come down. And what I'm hoping to see is a square add in this bottom corner. If I see a square pad in this bottom corner, we have the orientation correct. If we don't, then I haven't. And we got to play with it. So let's see what happens. Okay, it's just homed. It's now going to turn the light on. And our survey says, we do indeed see. Okay, so we'll press the stop button, enter. That's just going to lift up out of the way. And now we can just drop this board in place and get it aligned correctly. All right, now we're good to go. So this is a 30-second exposure. So here we go. We're going to let it expose. So once it does its first lift, we'll cancel. And theoretically, that should be all we need. Okay, so it's exposing now. As you can see by this part of the screen just here. Getting ready to hit the cancel button. In fact, I'll hit the cancel button, and then when it lifts, I'll just say confirm. I'll just speed that process up so I don't accidentally miss it. Not that it matters too much. Okay, that's now cancelled. Now theory says that that should now be exposed. I wonder what practice says. Come on, let's see it in chat. What do you think? Do you think this has worked, or do you think this is a bust? I mean, we are throwing spaghetti at the wall at this stage, right? Just to see whether or not it's stuck. So, as Mythbusters used to say, failure is always an option. But what do you guys think? Okay, I'm gonna peel. Interesting, interesting, interesting. Silomo's not sure. You and me both, Betty. You and me both. Right, so all I'm going to do is I'm going to just give this an IPA wash. I want to be gentle because any areas that are not done properly, I want to be a bit gentle on those areas, right? Okay. First impressions. Right, Libri? First impressions is okay. Yeah, I did have a little bit of fun with the thumbnail, right? Okay, I think we have a result. Okay, so these are the very fine traces. Now, this is mostly my fault in terms of possibly the saran wrap's not down and there's some wrinkles, but we're damn close, right? So 30 seconds is pretty much
it's pretty much there. The positives I'm going to take from that is that we have, come on, focus camera. We've got alignment. The pads are aligned across the solder mat properly. Both on the on the 2.5 millimeter pitch component, and also on the 5. So we've got alignment. That is awesome. Right. I've got a UV cure. It's a nail UV light, which I use to cure my prints. So I'm going to stick that in there and just give it a minute or so just to like cure off. 120 seconds, and I think that tells us that we're in a reasonable place, right, to get this applied to the real board. So lessons. Okay, what do we know? What do we know? So we know that the deployment of the solder mask is important to get a consistent coverage across the circuit board. That's the first thing. The second thing is we know that around 30 seconds, it seems okay. It's not perfect, but we could probably make it work. I think the reality is if I increase that to 40 seconds and I actually go back to the saran wrap and make sure the saran wrap is applied with no wrinkles, I think we can probably get this nailed. So I'm just waiting for the solder mask to cure under my light. It's a 2-minute cure, so it'll be done any second now, and we can take a look at it. Possibly under the microscope, in fact. Can I get the microscope up and running? Let me just quickly check this. Oh, what's wrong with the microscope? Oh, that's what's wrong with the microscope. That would be advantageous to actually turn the microscope on, to have it plugged into power. That would be really useful, Steve. Right, let's see. Oh, there we go. Have we got it? We got it. Yay! Okay, we have the microscope. Okay, so we'll just let this cure, and then we'll get a closer view of what's going on. But Alibri, yeah, thank you. It was. You can't take yourself too seriously, really, can you? Well, I can't anyway. Okay, so here is the solder mask. So surface cleanliness and coverage of the mask itself appears to be quite important. While we're not centered perfectly on the pads, we're centered sufficiently on the pads to be able to say that will work, right? That is going to work, right? And then if we have a look at the other side, we've got good isolation. Some of these pads are pretty close, but that's decent isolation. So what I think we've got going on here, there's a couple of things. So we've got possibly the surface wasn't clean. Maybe there's not enough solder mask in this region because we did kind of spread it quite thin. So maybe we need to put a bit more on.
the saran wrap may be a factor here too, right? So we got similar issues here. So I think we need to just have a look at the saran wrap, make sure it is as wrinkle-free as we can make it. Then again, looking across the board, there's let me just quickly check something. Right, it's not the wrinkles. That'd be that orientation. Oh, I suppose it could be. I suppose it could be. Okay, so it could be that we've got wrinkles in the saran wrap, and that's impacting the way that the UV light, is actually curing the solder mask. This bit here, that I didn't actually get the solder mask to the edge of the board, right? So good application is going to be key for us to get this right. But arguably, that is usable right there. Is it perfect? No. But this is a one-time use board, right? So it's cured. There's no residue. So I think what we'll do is we'll bump this up to 40 seconds. I'm going to get the saran wrap. Oh, right. Okay. We're going to go for it. Have you guys still got my audio? Yes, you do. Oh, cool. I thought for some reason then I'd lost you, but okay. So we're gonna give this a go. We're gonna try and get this real circuit board applied with a solder mask. So we need, first of all, to get rid of the wrinkles that you see here in this saran wrap. So I am gonna have to disturb my jig, which is less than ideal, because the whole point of the jig is for alignment. But I think in the interests of getting this dialed in, we need to get rid of those wrinkles on the saran wrap. So, yeah, we're just putting this down so that we don't have UV solder mask getting onto my screen. Now, how's the best way to apply this, I wonder? Oh, is that camera frozen? That camera has frozen. That camera had froze. Give me one moment, guys. I will get that fixed. Oh. What is wrong? What does baffled mean? Okay, let's just relaunch that and activate. Oh, great. My camera's died. That's just as, that's live streaming, guys. Technical difficulties. Okay, let me just reboot the device and see whether or not that fixes it, because a reboot of the app didn't. I tell you, what if I force stop it? Maybe that will work. Right, let's try that, because A reboot's going to be a bit of a pain to do, right? Information. We want to force stop. Okay, we force stop. And now let's relaunch the app. See, we're doing diagnostics. Okay. Will it activate? No, it will not. Okay, so that's going to go down for a reboot. That is somewhat disappointing. Okay, here we go. Let's send this device down for reboot. And then, right, while that's going on, what do you guys see? Do you see, you should be able to see me at the very least. So let's go here and go here and all right. So I'm going to come over here and I'm going to continue working because, you know, we need to keep moving this project forward and all, where is that? Okay, that is on the top. Okay, perfect. Last thing I want to do is get some crud on my screen because the saran wrap is there to potentially or hopefully stop that from happening. And I've got to try and apply this in such a way that we get as fewer wrinkles as possible across the screen. It's quite a tight space. All right, I think that will do us. And if it doesn't, then it's gonna be workable, whatever happens, going by what I can see already. Okay, that's starting up. Hopefully we get the camera back. Yes, yes. Give me my apps. Anytime today. There we go. Okay. So hopefully now when I start this up. Yay! Okay, so I've applied the saran wrap back there. Hey, you're welcome in. So we have successfully applied a solder mask. It is not perfect, but we do have a successful solder mask application. So we're about to give this a shot on the rear board. So we've just put the saran wrap or cling film, whatever you want to call it, on the screen. And this is to protect it from the solder mask getting down onto the screen. And we're just going to put the jig back in place. Thankfully, I've got like locator pins, so I should be able to get it in and around the right place. As I said, worst case scenario, I'll have to take a rotary tool with a V-bit in it, and I'll just carve away any solder mask that's not where I want it, or is it a place that I don't want it, should I say. That's probably more an accurate description of what would happen. Okay, so we can now prep the board. We can now prep the board, and here's the real board. Let's get that switched over to here. All right, so this is the real board that we're going to be working on. And we're going to apply the solder mask material to it. We're going to cut a piece of plastic to go over the top. So let's do that first. Oh, this is starting to get real now because, you know, we're actually using the production board that I'm going to be working with. So this is like, now's the time not to screw up, right? Don't screw it up, Steve. Don't screw it up. I got to get this. I got to cut in a way that is comfortable, and I'm not being a doofus because I don't particularly want to cut my fingers because this scalpel is pretty dang sharp. Okay, cool. Cool. Good. All right. So next thing we're going to do is we're going to use a bit of steel wool, and we're going to just give this circuit board a once over with steel wool. And that's just to get any sort of oxidation off the copper. Okay, and now we've done that, we've now got a bunch of particles all over the place. So we need to make sure we got those off. So the first thing you're going to do is just do a magnet sweep. You just get some, I got steel wool on me, so I'm just getting that off. Just going to do a quick magnet sweep for any particles of steel wool on the desk. Anywhere this could become a problem. Okay. And now let's put that magnet to one side because that'll need cleaning. Okay, final thing to do is to clean both the circuit board and the plastic with some isopropyl alcohol. And that is just to get any final debris off the circuit board and the plastic. And to make sure we don't mess this up, we're going to use different pieces of tissue to clean. And all I'm using is just plain tissue and some IPA. I just want to get rid of anything because I don't want to get any metal pieces stuck under the solder mask, shorting out my traces, because that would not be good. That would really not be good. I would not be very impressed by that. Okay. All right, nice, slow, steady, intentional movements now from here on in. So let's get our solder mask. Yeah, exactly. You've got to break it down into manageable chunks, because if you don't, you end up getting a little bit confuzzled around what's actually going on. So I'm going to put a line of solder mask here, like that, and I'm going to put a line of solder mask over here, right? And I'm going to work that solder mask across I'm going to work it across the, let's make sure I've got nothing on my hands. All right, I'll work it across and try and move it towards the middle. But we'll see how this goes, right? So here goes nothing. All right, so let's get our squeegee. And I'm going to work the solder mask firstly this way towards the middle, and then this way to the edge. And I'm already wondering whether or not I've put enough on here. We'll see. We'll work this across the board. I'm hoping the extra that I put on should be sufficient to get a decent coverage. But what I'm seeing right now is maybe not so much. So I want all of the copper encapsulated. Whatever happens, that's the primary function of the solder mask is to encapsulate the copper. So if it doesn't do that, it's failed. And what I'm finding is, as I'm squeegeeing, I'm sliding the sandwich material. I'm sliding that around, so I need to try and find a way of squeegeeing and not disturbing the PVC as much as I am. Okay. Sorry for the lack of commentary here. I'm focusing on. I'm hoping you can make out what I'm doing. Still sliding around the place. Okay. So where I've been pressing my fingers, it's light on solder mask. So let's get that through there. Oh, that works. Okay, so if I swipe across the copper multiple times, that does seem to just balance everything out and evens out the layer of solder mask that we're applying. Okay. So that's not too bad. It's not perfect. That's actually pretty cool. Got to make sure I'm not getting UV solder mask all over myself here. Doesn't help that I'm starting to get a bit sick, but we soldier on. Okay, we'll just give that a bit of a wipe around the perimeter, and I think we're good to go for an attempt. We're good to go for an attempt, I think. So let's flip this over. Huh. So let's hear it in the comments. Let's hear it in chat. Do you think this is going to work, or do you think this is going to fail? What is your thoughts? Just even it out where I've just been pressing down and moving things around. Okay. There we go. We're good to go. I can see I've got UV mask on my hands here, so I've got to be careful what I touch. Let's just slide this so that it doesn't interfere with our registration. Check I haven't done anything that would impact that. Okay, here we go. You probably need to take your PVC before at least 2 sides. I think we're good to go. I think this is gonna. I can see a couple of imperfections, but I mean, it's got to be good. It's got to be good enough, right? It doesn't have to be perfect. Let's not let perfection get in the way of progress. What's it saying? Don't let perfection be the thief of progress. I think that is the saying. So let's not. Okay, here we go. So let's drop that in. Okay, we're aligned. So I just need to clean my hands a second because I do have a UV, the solder mask on my hand, a gloved hand, admittedly, but I just don't want to spread it around the place. Got to try and keep mess to a minimum. All right. So we know that 30 seconds is marginal. Okay. So what we're going to do is we're going to do the solder mask run for 30 seconds, and then we're going to cancel it, and then we're going to run it again for another 10 seconds. So let's do that. Here we go. So here is the first exposure of 30 seconds. That's 20. Okay, so that's the first batch of 30 seconds. Then we're going to go again. This time for 10 seconds. Okay. Let's see what we got. Hopefully I did a good one. Hopefully I did it good. Yeah, I could get a spray bottle. This stuff is quite thick.
Right? Okay, so let's do the big reveal, shall we? What do we think? Do we think this is going to work? Or do we think this is going to fail? Oh my word. Here we go. Okay. That's looking incredibly positive. Okay. Let's get rid of that. I'm using that as single use. All right, let's get some isopropyl alcohol. And let's see what we got under here. Let's do the large pins first, shall we? I can see it's not perfect. I can see that there are bubbles, right? But, you know. Okay, that's pretty dang cool. I'm pretty pleased with this already. Oh yeah. Okay, don't want to rub too vigorously because I can see things starting to bubble. Okay, let's just quickly throw this in the cure station. Fully cure it, and then we can take a look for that some FEP. Yeah, FEP probably would be good. I don't have any FEP sheet that I can use as something which is disposable though right now. I'll have to get some. Okay, so that's the test article. All right, so we're just going to cure this now, and with any luck, we are going to have a solder mask. Yeah, that's what we're doing. So we're going to clean this. We're cleaning the solder pads, and then we're going to cure. And while we're waiting for that, I'm just going to tidy up the bench so that I don't end up sticking my arm in some curable solder mask, right? And then we'll get it under the microscope, and you guys can see the result. Oh my word. This has been a bit of a journey and a bit of a learning experience, which is the whole reason, you know, for the experiment is to learn. We successfully etched the circuit board, and it looks like we successfully applied a solder mask. That is just come on. I'm loving it, to be fair. So I will need to just like test things with the multimeter to make sure that I haven't got anything stuck under the solder mask that could potentially short the pins out. But drums, please. Here we go. So the application of this to the board, a clean board, is paramount, okay? And that's why we're seeing these pop marks. I'm not overly worried about that though, because it's more around the pads that I'm interested in. So here is the solder mask applied to the pads on the 5mm screw terminals. That's not bad at all. I mean, it's not perfectly centered, but okay, that's totally usable. The question now comes is, what does the other side look like? And that, again, while not perfect, that is totally usable. That is totally usable. I'm well impressed with that. I tell you what I just spotted that I'm going to need to be incredibly careful of. So right there, there's a tiny piece of copper just poking out just there. And that, to me, says that that is the potential for a bridge. Again, we've got one here, here. Yeah, we're going to possibly need to come in with a cocktail stick and some solder mask and just touch these areas up. But for something that I have not been super precise with the alignment, because I had to use the printer. I've taken the jig away and brought it back. You know, I've messed around with things. So if I've done this in one consolidated process, this would have worked. This has got me thinking, I wonder how well that this UV solder mask would work as an acid resist. Should I use this as an acid resist? Yeah, you're absolutely right. I think I'm gonna just touch those little points up with a cocktail stick, and I'll just dab a little mask in there and just make sure that they are isolated completely. In terms of that question, it's the registration for the board. Do you have to adjust your actual image? It's the registration of the board, because I took the jig out and I put it back in, right? So should I have the same? I'm guessing that comment is around using it as an acid resist. Yeah, I mean, it's getting the application just so. SR, what should I review? I'm not quite sure. Right. So there we have it. We have a little bit, a tiny bit of touch-up work. I've got to just buzz these out, and then I can get to actually drilling the holes for the components, and then getting this all put together. I'm pretty 3D printable conductive material. Yeah, I mean, I'm interested. I'm always interested in looking at new things, right? That is a given. Whether it's applicable here, Yeah, yeah. And that's the thing with live chat, is that there's a delay between something that I'm saying and you being able to respond. Minimum is around about 30 seconds. So you'll type a comment, and I've already moved on by 30 seconds. So I'll read your comment, and if it's a literal reply to what I've just asked, like a yes or no, I will have lost context in that. So, you know, that's the joys of live streaming, right? But yeah, that is totally usable. I've got to touch it up, drill some holes, and then we can get down to actually doing some work. So I'm really, really pleased. Oh, I saw you. No need to apologize. No need to apologize. All good. It's all good. Right then, guys, I'm going to call it there. Feel free to leave a comment under this video if you're watching the VOD on how you would do this differently. What would you change about what I have done to get the quality a bit better? For example, what could I have done to prepare the board so I get less imperfections in the solder mask, and possibly even the application of the etch mask? I want to keep this in context for the experiment that we have done. I don't want to see answers like, go use a third-party board manufacturer, or go use a CNC machine. In terms of using a resin printer, a UV resin printer, such as the Anycubic Photon S, yeah, that's normally used for resin-based 3D printing, what would you do differently that potentially would improve the quality of the result that we've got today? The quality of the result I'm happy with. It's acceptable. It's going to allow me to progress. But it's far from perfect. So what would you do? Okay, couple of thanks. So thank you for everybody who's hung out in chat and has chatted, commented, whether you've lurked or whether you've interacted. I appreciate you. Savvy, thank you so much for the super chats. I appreciate you, buddy. And, just as a little thing just to say, I have enabled memberships on the channel. So memberships, what memberships will give you, first and foremost, it will help support the streams that I do. It will help you buy better materials, better products, go more in detail, more in depth on tutorials and so on. But what do you get out of it? Well, there's a bunch of perks that you can check out on the membership page, but not to diminish anything, but from the workshop tier and above, you get access to the Discord server, the private Discord server, and there you will have early access to my videos, and you will also get access to the 3D files that I have for my project. So things like the CNC machine, once that's complete and dialed in, they will become available. There will also be discounts on merch that I'm planning on getting up on my shop very soon. So if you feel like you want to contribute and support the channel, consider memberships if that is something that you find interesting. If not, I appreciate you watching, chatting, etc. So until next time, keep fun, be safe, and make something cool. Bye for now.